Good day everybody, we got an interesting question. Foremost, let me draw the figure. The requirement of the question is to get the area of the triangle ADE. So we need to get the triangle. Okay, so this is A, B and C. This is given to be as 90 degrees. Now so this is the angle we have to find. In the previous question I have shown you how to get this angle. So A, B, C, I take this as D, I take this as E, and let me take this to be the center. Okay, I'm trying to put the center in such a way that it is acceptable. Okay, that's the center. Now we are interested in obtaining the area of ADE, and we are given this side to be as 4 units. We are not given anything about AB. Now what we have to do is we will have to obtain the radius. There are a few things we will have to do. We will have to get the radius, and there is also another information that is given. It is given that the area of the triangle is equal to 6 units. Now when I say area of the triangle, we are talking about the triangle ABC. So let's see how to do that. The foremost, I wish to get the value of M. So for that you can use this shortest way. Now this is the center. Let me take this as O. From the center I am drawing perpendicular to the tangent. Now if you draw a line, in fact it's a line drawn from O to D, this line which is drawn from the center to the point D, it's actually the radius, and according to the tangent theorem the angle made between the radius and the tangent is 90 degrees. Now what I wish to do is I would like to draw another line to this tangent. Let me take this as F. There is a tangent at F, so I will be drawing, connecting this thing. Okay, so please ignore this line. Now this line has to be ignored because I'm trying to get a central angle here, so just ignore this. Now this is making an angle of 90 degrees, and clearly This is 90, this is 90, this is 90, and this is a quadrilateral. So sum of the angles in a quadrilateral is going to be 360 degrees. Now clearly we see that angle D plus angle C plus angle F plus angle O, all of these three, angle A, D 90, 90, 90, this is going to be 270. So angle O is 360 minus 270, which is going to be 90 degrees. So this is clearly 90 degrees, right? So this central angle which we have obtained is 90 degree. Now since we have a central angle and since M has to be found, M is nothing but half of 90 degrees, which is nothing but 45 degree. So M is 45 degrees, right? Now what I wish to do, I know this is the center. From the center I wish to drop a perpendicular bisector to the point E. So there is a perpendicular bisector here. Now this entire angle M is 45 degree. Now drop the perpendicular bisector, so that means this part is going to be 22.5 and this part is going to be 22.5. You agree with me? Okay. Now clearly you see that over here, this is the radius, right? This is the radius. OD is the radius and OE is the radius. Now OD is equal to OE is equal to R. Both of them are radius. So that means two sides are equal. OD is equal to OE. That means this entire triangle ODE, therefore ODE is an isosceles triangle, right? Now that means OD and OE will have the same base angle, right? They will make the same base angle. Now since OE is a perpendicular bisector, I have dropped a perpendicular bisector from O to E. This part is 22.5, so this part will also be 22.5. If this is 22.5, this will also be 22.5, right? Fair enough, because of the fact that DOE or ODE is an isosceles triangle. So this is going to be 22.5. Now this is 22.5, this is 22.5. Therefore I need to get this angle between the radius. So therefore if you are going to be calculating the angle on this side, that would be, let me write that down, 22.5 added with 22.5, both of things added, and then we subtract this quantity. What is this? This is nothing but 45. So to get the angle at O from 180 degrees, I subtract 45. What is that? That's going to be 135. So this angle is going to be 135. Let me write that down. This is going to be 135 degrees. Fair enough, right? Now what is DE? DE is a chord. Since DE is a chord, let me write that down. Is a chord. So the length of DE. So what is the length of DE? That's nothing but R 2 times R sine of theta divided by 2. That's a formula. So that would mean 2 times. Now we need to get the value of R, right? Because R has been featured here. I was under the impression that we don't have to get the value of R, but R is featured here. So let's move on. So 2 times R of sine, what is that? Theta is 135 degrees. So this is 135 degrees divided by 2, which is nothing but 2 times R of sine 67.5 degrees. Now what is sine 67.5 degrees? Now in fact I have done a video to calculate sine 67.5 degrees. I don't want to show the steps here because it will make the lesson too long, but I have put in the link where you can watch how to extract the value of sine 67.5. Now this has got a value as square root of 1 positive root of 2 divided by 2 times root 2. This is the value for sine 67.5 degrees. So this is my DE. This is the length of the side DE, right? Now we will have to, I was under the impression we don't have to obtain the values of r, but we need to do that. So now what we will do is we will have to calculate the value of r. There is no other way for us except to evaluate the value of r. So with that, what I wish to do is I would utilize the data given in the question. It's given that AB is equal to 5 units and BC is equal to 3 units, and the area of the triangle being given as 6 units. We will be able to calculate the value of r. Now for that, what I wish to do is I would like to connect this point with this vertex. Okay, so what do you have? You got a triangle there, right? Then I wish to connect this point with this vertex B. So I got a triangle there, I got a triangle here. So if I were to take this as T1 and T2 and T3, then I can write area of the triangle ABC is equal to area of T1 plus area of T2 plus area of T3, right? Now what is the area of T1? Now this is the this is the height is r units, right? And the base is 4 units, right? So area of the triangle formula, we'll use this formula. Area of triangle formula is given to be as half times base into height. Now my height in this case is r units and r units, right? So that's simple. So it's given as area of triangle ABC is 6 units and area of triangle T1 is half times T1. What's the base? The base is 4 units, height is r units. So 4 times r plus half times area of triangle T2. The base is 5 units and the height is r units plus half times area of T3. T3, the base is 3 units. It's given as 3 units and the radius is r. So take it as it is. Now I can take r over 2 as common. I get 4 plus 5 plus 3. 9 added with 3 gives me 12 times r divided by 2. 2 divides here 6 times. So 6 is equal to 6r. Therefore r is equal to 6 over 6, which is equal to 1. So r is equal to 1 unit. Now we have got that r is equal to 1, but the chord length, if you remember, the chord length DE is 2 times r of, let me write that, D is equal to 2 times r of root of 1 plus root of 2 divided by 2 times root 2. So this is going to be 2 times r is equal to 1 root of 1 positive root of 2 divided by 2 times root 2. So this is my DE. So this is the length of one side. Okay, now let me go back to the figure. Now this is 22.5, this is 22.5. Now this radius makes an angle of 90 degree with a tangent. So that would mean this side is also 90 degree. But I would like to get the angle for this. I want to know the angle of this. So from 90 degrees, I have to subtract 22.5 degrees. This will give me 5. From 9, I take away 2, I get 7. This is 8. So from 8 you take away 2, 67.5. So this side is 67. This angle is 67.5. This angle will also be 67.5 because we are dealing with the isosceles sides. AD and AE is isosceles. Now, why is it isosceles? I'm going to show you in a minute. So let me write that down, 67.5. Now you might be asking me, why is it isosceles? Now it is isosceles because of the tangent theorem. Because if you were to draw, you can call it as external tangent theorem. If you were to draw a tangent from an external point to the circle, then the length of the tangent will be same. AD will be equal to AE, right? That is the external tangent theorem, or I would say exterior point theorem, different books give it different names. So the theorem is as follows. If you were to draw a tangent from any external point or a point which is outside the circle, and if two tangents are drawn to the circle from the same point, then the length of the tangents would always be same. So that would mean AD will be equal to AE. So that is one particular point that we need to observe. So because of the fact that they are equal, naturally the angle made by the equal sides with the base will be same. So 67.5 will be the angle that is being made by AD and AE. So having mentioned that, clearly we have just got R is equal to 1. So I know that this is a quadrilateral, right? And all four sides have to be R because of the fact that they are all the angles that I've just mentioned to you in the earlier start of the session. All of them are making an angle of 90 degrees. Thereby this is a square. So we are dealing with R is equal to 1. So that would mean this is 1 unit, this is 1 unit, 1 unit, 1 unit in all directions. So if this is 1, right, this side is 1, and just now I mentioned that the tangent drawn from an exterior point to the circle, or in other words the two tangents drawn from the external point to the circle will be of same length. So if this is 1 unit, AD is going to be 3 units. So this is going to be 3 units. If AD is 3 units, if this is 3 units, naturally AE is going to be 3 units. So these two sides are 3 units, right? But AB is 5 units. So that's okay. So we are on the right track. Now we are expected to obtain the area of ADE. Now this is the side which is occurring twice, and this is the base. So we will use the formula which incorporates the angle between the base and the sides. So let me write the formula. So therefore area of triangle ADE is equal to half times A times B times sine theta. Now A is the side which is occurring twice, so you place that. B is the side which is occurring as the base, so this is the base. So this is B, this would be the value. So what is the value when R is equal to 2? So it's going to be 2 times of square root of 1 positive root of 2 divided by 2 times root 2 times sine theta. Now what is sine theta? Sine theta in this case is 67.5. Can you believe that? This angle is 67.5, and we have already got the value of 67.5. Sine 67.5 is known. So this is a lovely, it's turning out to be a lovely question for the fact that we've got such a beautiful value. Now 2 can be cancelled, so you got 3 times the root of 1 positive root 2 divided by 2 times root 2. This is multiplied with root of 1 positive root 2 divided by 2 times root 2. So square root will get eliminated, giving us 1 positive root of 2 divided by 2 times root 2 multiplied with 1 positive root 2 divided by 2 times root 2. Now this can be multiplied, and that will give us 1 positive root 2 root of 2 whole square divided by 2 times 2 is 4, root of 2 times root 2 is 2, so 4 times 2 is 8, so you got 3 over 8. You expand this, you get 1 positive 2 times root 2 positive root of 2 squared is 2. So this is 1 added with 2 is 3, 3 times 3 is, now let me place the value, 3 positive 2 times root 2, and you got a 3 over 8 here. Now if you want, you can multiply them and extract the value. If you are interested in giving an approximation, I will give an approximation. If not, you can simply leave this as square units. So this is the area, right? Area of ADE. So this is the final value. Area of the triangle ADE is 3 times, I should say 3 over 8 times 3 positive 2 times root 2. As I mentioned to you, if you're not happy with this, you can take the value of root 2 as 1.414, then multiply it. That would give me 2 times of 1.414. It's going to be 4 2s are 8, 2, 8 2.828, you add 3 to it, that's going to be 5.828, and then you multiply 3 and divide by 8. So 8 3s are 24, 2, 3 2s are 6, 8, 8 3s are 24, 2, 15, 16, 17. So 1, 2, 3, 17.484 divided by 8. You can divide this by 8. So if you were to do that, so 17.484 I divide by 8, 8 times 2 is 16, 1, 14, 5, so 5 8s are 40 and 5. So the value is approximately 2.18 and 55. This is the approximate value when you evaluate this, 2.1855. so having given you the final solution, it's a good place for us to stop here. Everybody, thank you all, enjoy your night, and please like the video, subscribe the video, and enjoy your day.